In this video, we introduce some basic concepts in integral equation. The first concept is Fredholm integral equation. In Fredholm integral equation, all things remain the same except this lower limit and upper limit. In Fredholm integral equation, the lower limit is fixed. It means that it is a number. And the upper limit, we have a fixed number. So how you memorize this Fredholm integral equation? You can memorize it by using some kind of trick, which is since since Fredholm integral equation, the first letter is F. So you actually remember that with fixed limit. So in Fredholm, F is fixed limit. That's how you memorize it. The second one is Volterra integral equation. In Volterra integral equation, there is a lower limit which can be a constant, fixed, but the upper limit is a variable. But it can happen that the lower limit is, for example, variable and the upper limit is also variable. It can happen that we have two variable limits. In that case, also the integral equation is called Volterra integral equation. So this is an example of Volterra integral equation. There is nothing difference except the limits. When the limits are fixed, this is called Fredholm. When the limits are one of the limits is variable, then this is called Volterra integral equation. Then there is another definition which is known as Fredholm integral equation of first kind. It means that there is one unknown function. In this equation, there is only one unknown function. This unknown, or maybe that unknown function, appears only once. This kernel is known, this function is known, u of t is unknown, and the limit is fixed. That's why we have Fredholm, and u of t only appear once in this equation. So it means that this is Fredholm integral equation of first kind. So how you memorize it? First mean there is only one unknown. Just take a look. Here the kernel is x plus t and the function is known. It can be, for example, sine x. The only unknown in this equation is this u of t. So this is called Fredholm integral equation of first kind. Similarly, here you can see that the lower limit is fixed, which is infinity. The kernel depends on x minus t. It means that kx minus t, there will be sine x minus t or maybe cos x minus t. So it means that there will be a kernel which depends on x minus t. Function f of x is known, u of t is unknown. There is only one unknown in this equation. So this is Fredholm integral equation of first kind. Why this is Fredholm? Since the limit is fixed. Now If we talk about Volterra integral equation of first kind, it means that the limit is variable. The only limit is variable in here in upper limit. U of t appear only once, which is unknown. So it is Volterra integral equation of first kind. Here you can see that this is known, which is f of x. This is kernel, and then we have u of t. Remember that in future we will use a different symbol for unknown. We can use, or we will use sometime phi of t as an unknown. So this is called, this is called Volterra integral equation of first kind. The limit is variable and there is one unknown function. And you can see yourself, this is also Volterra integral equation of first kind, since there is only one unknown and one means first, just to memorize the classification. Okay, now this is example number 3, and you can see yourself the limit is variable, so it is Volterra integral equation, and there is only one unknown, so it is first kind, Volterra integral equation of first kind. Although we will solve integral equation in future, here you just see a simple example. This is our integral equation. The limit is variable, so it means that this is Fredholm. I'm sorry, this is Volterra. This is Volterra integral equation, since the limit is variable. Differentiate both sides and apply Leibniz rule over here. Leibniz rule says that first you take a derivative of upper function. So we take a derivative of upper function, then put x into this whole equation, this whole expression. So this becomes fx and x. Remember that you have to put the upper limit in this whole equation. Then the lower limit is fixed, which is 0, and then we have plus 0 to x, partial by partial x minus t, u of t, d of t. All the other terms are 0. So what we get this term. Differentiate again. When you differentiate this again, d by dx, 0 to x, u of t, dt. Apply, for example, chain rule, Leibniz rule, Leibniz rule, or you may simply say that the integration and derivative cancel each other. We will get u of x is equal to 2. So this was all about the classification of Volterra and Fredholm integral equation. Try to memorize it. This will help you in future. Thank you for watching.